Okay, we're on Algebra 1, Lesson 12.5, adding and subtracting rational expressions. So let's start with our warm-up. We're just adding fractions. I know you guys love fractions, so let's really pay attention to all this. All right, so because I have a common denominator, I can just add straight across. So I get 6 over 4, which if I simplify it is 3 over 2. Same thing, common denominator, I get 6 over 6, which is 1. Okay, I don't have a common denominator, so the least common, I have to find the least common multiple, and that's 12. So in order to get this to 12, I would have to multiply by 4 on the top and the bottom. Remember, if I do it on the top bottom, I have to do it on the top, and the other side I have to multiply by 3. So that makes 12 for this first one and 3 on top, plus 8 over 4, 8 over 12, obviously I'm making a common denominator. So when I combine 8 and 3, I get 11 over 12, and I can't simplify it, so I'm done. All right, common denominator of 5 and 2 is 10. So to get 5 to 10, I need to multiply by 2. To get 2 to 10, I need to multiply by 5. So that becomes 5 over 10 plus 4 over 10, which is equal to 9 over 10. Okay, so now we're going to subtract. Nice and easy, I've got the same denominator, so that just equals 4 over 8, because 5 minus 1 is 4, which is simplified to 1/2. Okay, when I subtract, if I have a minus and a minus, it becomes a plus. So 4 plus 1 is 5 over 3, and you can leave it as an improper fraction. All right, 9 and 5, they're not common denominators. So my common denominator is going to be 45. So to get this to 45, I need to multiply by 9. And to get this to 45, I need to multiply by 5. So that becomes 35 over 45 minus 9 over 45, which is equal to 26 over 45, because 35 minus 9 is 26. Okay, there's no common denominator here, and yeah, I can put 1 over 1, but I still need a common denominator. Well, it's easy with ones because the common denominator is whatever the other one is. And if it's a whole, that means I need to have a 5 over a 5. So 2 over 5 minus 5 over 5. 2 minus 5 equals 3 over 5, negative 3 over 5. So today we're going to talk about adding and subtracting rational expressions with like denominators, and then also how to do this with unlike denominators. The rules for adding and subtracting, or for adding rational expressions, are the same for adding fractions. If the denominators are the same, you just add the numerators and keep the common denominator, just like we did in the warm-up. So, for example, if I have a, b, and c to represent a polynomial, so if I have a over c and b over c, if I have a common denominator, I just add those together and keep the same denominator. So let's try one. Okay, well, let's look. Do I have a common denominator? Yes, they both have a common denominator of x to the 4th, so I just simply add 2x plus 4x over x to the 4th. I can combine the 2x and the 4x and get 6x over x to the 4th. I can cancel out that x with one of these x's, so I'm just left with 6 over x to the 3rd. Okay, let's look. Do I have a common denominator? I do. So again, I can combine these all together, and I get m squared plus 2m plus 3m plus 4 all over m plus 4. Now I'm going to combine like terms, so I get m squared plus 5m plus 4 over m plus 4. I'm going to factor the top of m plus 4 and m plus 1 all over m plus 4. Now I can cancel the m plus 4's, and I get just an m plus 1 all left over. So again, the factoring is not going away. You need to know how to factor. Okay, k squared minus 16, same thing, common denominator. So I'm going to take the 18 and add negative 18 and add 6. So that becomes a negative 12. So I've got 3k, sorry about that, 3k minus 12 over k squared minus 16. I'm going to factor out a 3 out of the top. On the bottom, it's one of those perfect square binomials. So I've got k minus 4 and k plus 4. So now I can cancel these k minus 4s, and I'm just left with 3 over k plus 4. So again, up here at the top, in case you're wondering, I did 3k minus 18 plus 6, which that's how I got this 12 here. All right, so subtracting is a little bit different. To subtract rational expressions with like denominators, you would have to add the opposite of each term. So the negative sign has to carry over to everything. So for example, if there's a minus, we've got a common denominator, so we're good there. This has to carry over to both of these terms. So my top becomes 6y minus 6, that's what this was. Now I have a minus y and a minus 4. All over y squared plus 4y minus 12. I'm going to combine my like terms. 6y minus y becomes 5y. Negative 6 minus 4 becomes negative 10. All over y squared plus 4y minus 12. Now I'm going to factor my top and my bottom. I'm going to pull 5 out of the top. And I'm going to factor my trinomial on the bottom. So I've got a y and a y. And I know that I want to make 4, so I'm going to use a 6 and a 2, and I'm going to have a positive 6 and a negative 2. These will cancel, and I'm left with 5 over y plus 6. So main thing, this negative sign has to go to everything that is being subtracted. Make sure you add the opposites of all the terms in the numerator of the second expression. Okay? Okay, so here comes the tricky part. So if you haven't been paying attention, this is the last part of the lesson, but it gets a little tricky. With fractions, and as with fractions, rational expressions have to have a common denominator before we can add or subtract them. If they don't have a common denominator, we have to use the least common multiple of the denominators to find one. To find, this is kind of a long route to find the least common multiple. So I'm going to show you the long way. If you think you understand it, you can do it the short way, like I'm going to show you in a little bit. Okay, so we need to find the least common multiple. So let's say these were our two denominators. What we would do is we would list out the prime factorization. So meaning to get 6x squared, I would do 2 times 3 times x times x. And to get 8x, I would do 2 times 2 times 2 times x. And then to get the least common multiple, you take basically everything that is used. So I need to use 3 2's. I know I have to use a 3 from up here, and I need to use 2 x's. So my least common multiple is 24x squared. Basically, the least common multiple is the smallest value that both of these can be divided into evenly. Okay? Now, with polynomials, it's a little trickier. What you want to do is you want to factor them. So if I have, let's say these are my two denominators. If I had 5x plus 15, and I would factor out a 5 and get 5 times x plus 3. And if I factored this binomial, I'd have x plus 3 and x minus 3. And then basically what you have to do is you have to use everything that this one has. These both use one of these. And then because this has an x minus 3, we have to use that. So least common multiple becomes a part of all of them. So that's a little trickier. So let me show you here. So doing this the long way, if we were to write out the prime factorization, I would have 3 times x times y times y times y. And then down here, I would have 2 times 3, and then times x times y, okay? Now, what do I need to use? Well, I need to use these 2's, and I need to use at least 2 3's. So 2, 2, 3, and 3. I need to use at least 2 x's and at least 3 y's. So my least common multiple is 36x squared y cubed. Now the other way to think of this is look at the number out in front, 9 and 12. Come up with the least common multiple that both of those go into. So if you think about it, the only thing is going to be 36. 9 can go into 36 and so can 12. Then to get the variable part, you take the bigger of the two. So there's an x here and an x squared, so we have to use the x squared. And then since we have a y and a y cubed, we use the bigger one, the y cubed. So that's the other way of just kind of looking at it if you don't want to write it all out like that. Sometimes writing it out gets confusing. If you like that method, you can use it. Okay, so now how to find the least common multiple if I have a polynomial. So what I have to do is I have to factor both of these. So I've got 2 right here. I'm going to factor this so that I get a c plus 5 times a c plus 3. I'm going to pull a 3 out of here, so I get c squared plus 6c plus 9. And now I'm going to factor this into c plus 3 times c plus 3. Okay, so now I've got this and I've got this. Well, I know I'm going to have a 3 in my answer. I know that I need at least 2 c plus 3s, so 2 of those is squared. And then because this has a c plus 5, I also need a c plus 5. So this is your least common multiple. You're basically taking parts that all of them have and coming up with what they all, your least common multiple. The LCM of the denominators of fractions or rational expressions are also called the least common denominator, or the LCD. You use the same method to add or subtract rational expressions. So what you have to do is you have to get a common denominator. Then once you find that, you're going to multiply the top and the bottom by whatever makes that common denominator. Combine, either add or subtract, factor, and simplify. So this is a multi-step process here. So let's go through a few examples, okay? All right. I don't have a common denominator. So what I need to do is I need to figure out what goes into both, what is the smallest number that both of these can go into. Well, 5 and 2, I'm not going to do this by listing out the least common multiple. I think this gets tricky. What is the least common multiple of 5 and 2? The smallest number that they both can be divided into is 10. Then we look at the n cubed and the n squared. And I said you take the bigger of the two. So since we have more of these, I have to do n cubed. So my least common multiple is 10n cubed. So let's rewrite our fraction, and I'm going to show you what to do with that now. Well, if I want to make the denominator, this is going to be our denominator, least common denominator, I need to figure out what do I need to multiply by to get that. Well, 5n cubed, in order to make it 10n cubed, I just need to multiply it by a 2. If I do it to the bottom, I have to do it to the top. For the 2n squared, in order to make it 10n cubed, I need to multiply it by a 5 and another n. And if I do it to the bottom, I have to do it to the top. So now I'm going to get 10n cubed on the bottom here. 2 times 2n becomes 4n, plus these become 10n cubed, that's good, and 4 times 5n becomes 20n. Good, now I've got a common denominator. I can actually combine the 4n and the 20n. So this should be, did I mess something up? Yeah, this had an n up here when I rewrote it, so this should be squared. So now I combine the 4n and the 20n squared, so I get 4n plus 20n squared all over my common denominator of 10n cubed. I need to factor, so I'm going to pull out a 4n out of the top, so that leaves me with a 1 plus 5n over 10n cubed. I can cancel one of these with one of these. I can pull a 2 out, and I'm left with 2 times 1 plus 5n over 5n squared. If you want to distribute this back, you can rewrite it as 2 plus 10n over 5n squared. All right, I know that was a long process, but go back and watch me do it if that did not make sense. All right, adding and subtracting again. I have a very similar common denominator, but if you notice, they're not quite the same. They're opposites. So in order to make them the same, basically I just have to pick one of them and multiply it by a -1. So if let's see, if I rewrite this, I'm just rewriting these. You can do the first or the second one. I'm going to multiply this by a -1 on the top and the bottom. So now I get a -2 over, it makes it the same, the opposite binomial, so they are the same denominator now. Now I have a -2 minus 5 on the top, so that becomes a -7 over my common denominator of w minus 5. Well, there's no simplifying needed, or there's nothing to factor out, so we're just kind of done there. Okay, so those are all the examples. Just to reiterate here, let me go back to this example up here. We keep going. You're figuring out what is the least common value that both denominators go into. So up here, if you wanted to list out the prime factorization, you can. I like to just look, and I know that the greatest common or the least common multiple of 5 and 2 is 10. And then I look at the variables, and it's always the bigger of the two. So you have to figure out then, what do you need to multiply each denominator by to make it that least common denominator? If there was another variable up here, like let's say there was an x here, you would have to include the n cubed, and you would have to take into account the x. So anything that they have, you have to take into account. If you look in your book, there's some more examples, and I will help you guys with this as well. We'll go over it. So that is all.